So I'm going to be talking about logging and monitoring on Kubernetes applications. So pretty much here, I'm just going to give a quick use case on using Datadog to achieve these goals. So first of all, my name is Felipe. I'm a software engineer at KI Labs here in Lisbon. We pretty much are a company who brings innovation and startup culture to big corporations. So I'm going to start off with a few fun facts regarding Kubernetes and containerized applications. So pretty much on average, any given host in an orchestrated environment is running 8 containers. The average lifespan for a Docker container in an orchestrated environment is about 12 hours. And over half of the Docker environments, which are orchestrated instead of being standalone applications. So pretty much at the end, you get to have your Kubernetes cluster. And so now what? You want to push it to production. And what should you have in place first off? In order for you to have a production environment, you should have monitoring, logging, and alerting so that you know when one of these little things goes wrong, you're alerted about it and you know what to do, you know what broken it. So pretty much because of the complexity and the thing that Dockers are very ephemeral nature, so they don't last very long. Datadog is here to help us to monitor all the loggings and all the infrastructure in this case for this kind of architecture. So pretty much if you follow 12-factor methodology, you know that while you're designing for microservices and cloud-native apps, you should always log to std out, something that Kubernetes supports natively. You're going to be in the production environment who has hundreds of pods. And because they're ephemeral, you're not going to have log history within the containers because when you realize something went wrong, the container no longer exists. So pretty much you can log everything you want in a JSON format with as much data as you want to std out. Datadog is going to help you out to trigger some alerts based on those logs events. And Datadog enables you to deploy the solution, the Datadog agent, through Daemonsat, which is a very handy solution, which pretty much throughout the whole cluster, if you have your hosts, you just deploy the Daemonsat and it's going to attach the Datadog agent to every single host that you have in your Kubernetes cluster, and it reports back to the platform where you're going to have all the information. So I'm just going to show you very quickly here. Datadog. So I'm currently running an application in a Minikube, so my cluster, my local cluster. And what's happening here is on Datadog, everything that is happening within my cluster, I get all the logs here. So then I can search for either the host that triggered the log. I can get all the access logs. For any given log I can enrich it with as much information as I want. If something went wrong, so if I have an error log, I can attach the stack trace to it. Also, given the alerts, that you can set it up based on both logging and also other information such as the CPU, RAM of either the host or every single container and even the whole cluster itself. You can easily set it up some monitors, for example, for the CPU high usage, error logs, and any health checks. So all of these events are going to be here, and they can all be triggered through either like Slack channel, SMS, email, whatever your SRE wants. Then pretty much you have here like all of the events that trigger in the past. So if there were any error logs, you can simply post them all into a specific Slack channel where you can get all the devs looking at the logs whenever something goes wrong in production, so they can have that feedback in real time. Same thing, like if something is going wrong, if someone hacks into your machine and is using your CPU to mine some Bitcoins, you get those notifications as well in terms of the CPU usage, GPU usage, for any other metrics for the host. And also it provides dashboards for all type of information of how many containers you're running in your cluster. So CPU usage, pretty much all these dashboards are very configurable. You can set it up anything you want. In here, for example, you also get all the events for your containers. Whenever a container dies and needs to be spinned up again, you get all this information here. So for example, if I trigger, I'm going to trigger here a couple of exceptions. And also, I'm going to be here putting a little bit of computational power to it. See if, so now if we close here, we're going to start getting the initial ones. Just give me a second. But pretty much, for example, if I open here the monitoring part of it, I can have all of the spikes that happen in the history for the CPU usage. Given a bit, like I can try and come here and crash the solution a little bit, and we're gonna see those spikes in there. And also, if I go back here, I have here the, for example, if I select here for a specific event, I can come here and see this is the stack trace that happened. Also, one thing that enables you to inject any kind of context you need. So, for example, if for the initial requests, if you're getting a request here at the access log, you can simply inject a unique identifier, and then across all your services, you just need to pass that correlation ID, and you can pretty much see if something happened to one of your services, then you can see the whole workflow through your logs. Whatever happened, whatever triggered, can be achieved to that, because you can simply just like come here, or even like I want to search for. Just give me a second. For example, I can add here in this part of the hosts, I can add the unique identifiers, and I can simply click on correlate all the IDs, and it simply shows all of the requests based on only that user. So let me just go back here to the monitor. So as you can see, there's here the spike. It went over 40%. And my monitor says that if it stays on average over 40% on the last 5 minutes, then it's going to trigger an alert. So pretty much within a couple minutes is going to trigger an alert here that we're going to be able to see. But yeah, I don't want you guys to just stay here and look for those 5 minutes. But okay. So pretty much like you have a daemon set script where you can set everything. You can exclude and include certain images for your containers. If you just want to collect the data just from some certain images within your cluster. And then as I showed, you have logging analysis, any kind of alert monitoring, and also the infrastructure monitoring. So thank you. If you guys have any questions, feel free to ask. That's pretty much from my side.
So, how many of you are web developers? I guess a big part of you are web developers. Not that many people are web developers, apparently. So, do you guys know what a WebAssembly is? No one knows what WebAssembly is. Also, a great audience, so I can make all kinds of mistakes that you won't really know if I'm right or not. Anyway, WebAssembly is a very recent development in the web world, although it's not that specific to the web, since it's a kind of a general purpose instruction set, which can be seen somewhat similarly as something like the Java virtual machine in a way, for instance. So it's essentially what what it allow what it allows is to replace JavaScript with any other language um, and run that in a web browser. So I started working with WebAssembly like a few months ago, maybe I don't know, 6 months ago, let's say. Mostly for personal projects, for learning, mostly for learning, and the the idea of WebAssembly is to target different programming languages, whether it's C, C++, Rust, or any other, in the future, any other language. But at the moment, there's a restriction because the garbage collector part is still not implemented. So, but in the future, you should be able to run all sorts of languages, like Python and C#, for instance. It should be really, really easy to do it. Yeah. So, in my case, I decided to use Rust. So, the Wikipedia defines WebAssembly as a standard that defines a binary format and the corresponding assembly-like text format for executables used by web pages, which is pretty simple to understand, I think, if you're used to programming. So, as you might know, as a web developer, in the case where you are web developers and use JavaScript, it's not the most well designed language for some things, and WebAssembly was designed to fix some of those instances where JavaScript is not the most perfect language in the world. So it was designed to be parsed fast instead of JavaScript, which is a scripting language. So it needs to go through several stages in order to be executed. And since WebAssembly is like an assembly language, it's designed to run sequentially on a stack machine. So it runs according to some benchmarks. It's up to 20 times fast to parse, and the execution time it's very dependent on the kind of things that you're using. JavaScript is faster on some things, slower on other things, so it's kind of hard to have a good number for that. And it's also important to mention that it's supported in all major browsers since November 2017. So for more than 1.5 years. Yeah. Okay, so JavaScript WebAssembly is really easy to get running in the browser. So if you're used to using frameworks like, for instance, where you use TypeScript, like Angular, for instance, you just really have to copy paste a few lines and you'll get like a working project in no time. And at the moment, you can build a whole application in WebAssembly. So you just define like a main, as you will do in any other compiled language, and your program starts on that main. Otherwise, you can also write WebAssembly functions and use those functions in JavaScript, or vice versa. So you can export JavaScript functions to WebAssembly and run them on the browser. And you can also use all the APIs you have in the browser to, well, you can use all the APIs you have in the browser in WebAssembly. The biggest problem with that is that some languages aren't as flexible as JavaScript, and the API was designed to be used with JavaScript, so you get into some weird things like in one example, I was using a WebGL, and there's a simple function which is text image 2D, and the Rust bindings for that API turns out to be all those functions which are maybe 20, I don't know, and you can see it's very very verbose. It's kind of confusing when you're looking at the documentation, especially when the documentation wasn't meant for functions that long. Kind of breaks. And yeah, another big part where I had some troubles with WebAssembly was callbacks, because callbacks were designed to be run with JavaScript, which is mostly a single thread, was designed as a single-threaded language, so you don't really have problems like starvations and race conditions and that sort of things that you happen to have to worry about when you write multi-threaded code, which is going to be introduced in WebAssembly in the short-term future. I don't really know when, but it's being worked on. So you can't really just use callbacks as you will use them normally in JavaScript, at least on a safe language like Rust. So you have to do some trickery, which is somewhat complex and hard to get running. But once you fix it, it's the same thing everywhere. So it's mostly like a pattern, and you just use that pattern after a while. So, in conclusion, WebAssembly is a fun thing to use, for me at least. So you get not to use JavaScript in a browser, which is a big plus if you don't like working with JavaScript, or your program application is not exactly easy to model in JavaScript, or performance. You have some performance constraints that are hard to guarantee with JavaScript. So, like for instance, you might have run into lots of type problems with JavaScript when you have strings with numbers and you're actually expecting numbers, and then after running a few times you find out that you have to cast some things, etc. So, and all those sorts of things, some on large code bases, sometimes they become really hard to debug and find. So if you use typed languages and build them to WebAssembly and run them on browser, some projects actually might benefit a lot from that. You also have to get to skip lots of philosophical debates about JavaScript, like is it an object or a dictionary? What's the exact performance of calling a member of a class and stuff like that? And like I've mentioned before, it's not more complex than setting any other modern development environment, like something like Angular or Vue.js with if you're using TypeScript or React, for instance. So, but in practical terms, at the moment it's only relevant if you're working on high performance applications, which require where any speed improvements that you might get are relevant, like game programming or if you have some sort of real-time requirements. So if you're doing like stuff like augmented reality in software, instead of trying to leverage the GPU using shaders, for instance, you get a real benefit using that. You can see on the official WebAssembly page, you have a page full of use cases, but it's mostly for high performance stuff. And so in the future, you'll be able to import just a single WebAssembly file instead of importing a JavaScript file. You'll have real multi-threading. You'll have support for SIMD, which is simultaneous single instruction multiple data, which allows you to do vector math 4 times faster than you will normally, or even faster on some CPUs architecture and stuff. You'll have garbage collection, that, like I mentioned, so you'll be able to compile Python code to run in WebAssembly, which will be really beneficial for some use cases. So mostly for computing, for scientific computing, where Python is very used with stuff like SciPy and stuff like that. And eventually, you can even run WebAssembly in WebAssembly. So you can use WebAssembly as a scripting language. You might use WebAssembly as a general purpose scripting language for your application. So you can import WebAssembly code and run it, which will, in that case, will be something like Node, where you could do a lot of different things with that. So it's run WebAssembly in WebAssembly while you compile, while you run. I kind of forgot the meme, but this was the right meme. So yeah, if you have any questions, you may ask them after the presentations. And thank you for your attention. Yeah, and visit Valley Space booth while you're here, which is just over there. Thank you. Yeah, I'll just.
Hello, everyone. Can you guys hear me correctly? Cool. This is a very short presentation, 5 minutes, Ignite edition, 20 slides, 15 minutes each, no more than 5 minutes. So this is a new step for me, so let's see how it works. So, the talk is about JavaScript being the new English. This is a very old topic for me and very dear, but what do I mean with this? Eventually, I will tell you when the slide passes. JavaScript is becoming the English language of the programming languages. What I mean by this, I will try to decide it and help you come along with me in a trip playing around with words. So to do that, we need to go back to 2007 when I started doing full stack web development. I had to learn JavaScript, SQL, PHP, HTML, and CSS all at once. There was a funny ride. I eventually got stuff done, but it was a ride. But the thing is that when you change your language, your persona, your mind changes along with you. And this is a very strong thing. And it happens when you use a natural language or use a programming language. So whenever you change language, there's a tax on it. So here I am writing my JavaScript code when suddenly the client calls for a missing field on a form. So I have to add that form directly into the, I think it's the SQL, right? Yeah, I think it is, right? I have to, je ne parle pas SQL très bien, mais je pense que c'est facile. Je peux ajouter un camp aux tables des utilisateurs. Voici, select a baguette from omelette de fromage e ça marche. Alors, PHP. Non è il mio cavallo di battaglia. Devo cambiare un po', controllare e validazione per essere utilizzato in questo cazzo che non me acuerdo. Cualquier cazzo es eso. Yo creo que es HTML. Es con un pan comido, claro. Solo necesito escribir un poco de marcado de hipertexto. Es muy simple. Tú consegues hacerlo también. Ahora, após HTML, nós temos que fazer CSS. Utilizar inputs, grande cena, vai dar fixe, né? Yeah. Acho que vamos a fazer isto para o Chrome de Mac e o resto logo se vê. Afinal, isto é só para inglês ver, não é? E tenho que fazer uma coisa muito estranha, que é validar no client-side usando uma regex. Whoa, booming, bah! I have no idea what I'm missing and what I'm doing in all of the changes that are going through. So I have no idea, and the tax is feeling. The thing is that JavaScript, and whenever you want to innovate and constantly traverse barriers, the need for lingua franca arises. This happened before with Portuguese as a lingua franca, and now with English as a lingua franca, and it's happening as well with JavaScript as a lingua franca. So, what is a lingua franca? It's a language that is cross-culture, cross-platform, cross-boundaries, and cross-borders. So borders are a few of the new topic, and we are going to break down the borders. Which borders? Well, a lingua franca is on all continents, so it has to be spoken every single continent, right? So JavaScript was born in the continent of the browser, you see? Mozilla and Netscape gave birth to JavaScript, and it was born in the browser continent. It was very happy for a few years, not too much happy, but he decided to, when Chrome decided to show up, he decided, well, go forth, my son, and explore the world. So JavaScript entered the world of the server via the Node.js. So JavaScript extended away from the browser where it was born into Node. Afterwards, he said, let's get together. And both Chromium and Node got together and built Electron, in a sense. And JavaScript was now present in desktop applications. After all of this, JavaScript said, well, I want to go forward. So React was now then extended on iOS and Android continents with React Native. So JavaScript is now on the iOS and Android continent. It's new, it's exploring, but it doesn't stop there. So nowadays you can even go on machine learning and consoles and TVs using JavaScript, a single language to go and share your message across the whole world. It's fun and it's a very cool language to use. If you have it, please invest in it. And all of this comes to the conclusion that the Java dream, the write once, run everywhere dream, is actually a JavaScript reality. Not really as it sounds, it's learn once, write everywhere. It's very similar, but very, very powerful. But don't forget, just like music, you can listen to it with one speaker, but it's better to listen in stereo. So it's the same with language. You can learn one language, or you can learn two, or even more. 5.1, be multi-tenant, multi-language, multi-speaker. Learn JavaScript. That's it. Oh, questions. You have any questions for me? It's breaking the rules of an Ignite presentation. If you have any questions, just nag me around. I don't bite. I might seem shy, but I'll gladly talk to you about anything. Okay, thank you, guys.